Bismillahirrahmanirrahim. Students, today we will be able to learn properties of waves. That is, what is reflection, what is refraction, what is diffraction. So, first of all, we will discuss that what is ripple tank. It is actually a type of experimental setup. It is ripple tank is experimental setup in which we get the waves pattern, and with the help of these wave pattern, then we study reflection, refraction, and diffraction. Okay. It consists of a shallow glass tank of water used to demonstrate the basic properties of waves. The ripple tank is usually illuminated, means that light or it is lighted from above, okay, so that the light shines through the water. Some small ripple tanks fit onto the top of an overhead projector, that is, they are illuminated from below. Okay. Here I show you the diagram of ripple tank. If you look at this diagram, it consists of a shallow tank of water and oscillating pedal, and illumination or light is incident on it from above, and it also consists of a power supply, and a wave pattern are viewed here on the screen. Okay. So in this picture it is clearly showed all the features of this ripple tank. So ripple tank, with the help of ripple tank and it produce wave patterns, and with the help of these wave pattern we studies that what is reflection, what is refraction, and what is diffraction. All these properties we are able to study it. Okay. So now we are going to discuss one by one all these properties. So first of all, I am going to discuss what is reflection. Reflection is simply the change in direction of a wave or a wave front, okay, at an interface between two different media, so that the wave front return into the medium from which it is originated. Okay, means that reflection is simply the change in direction. Means if a wave is going and returns in the same medium and it is reflected, so and it changes direction and return to the same medium, so that is reflection. Okay. Suppose if you switch on the torch, okay, so that torch light will incident on a mirror, and that light will again come back, will be reflected in the same medium but in the opposite direction. Okay, so that is the reflection, and its common examples are reflection of light, sound, and water waves. All these they follow reflection. Or its another definition is reflection is when light bounces off an object. If the surface is smooth and shiny like glass, water, or polished metal, the light will reflect at the same angle as it hit the surface. Okay, so this is called specular reflection. Means one thing you must remember, that reflection always occur on a shiny surface, or from a glass, or with a polished metal. Means always it doesn't occur on a very rough surface, or so it always occur on a smooth shiny surface. Here I show you the diagram of reflection. If you look at here, so mirror is placed, incident ray, it fall on the mirror and it is then reflected. The green one is the reflected ray. Okay, and I is the angle which the incident ray is making, and R is the angle which the reflected ray is making. Here I show you another diagram of reflection. Again, all these labeling are shown in the figure, and here I is equals to R, means the angle of incident and angle of reflection must be same. Now we are going to discuss what is refraction. So refraction is the change in the direction of a wave passing from one medium to another medium, or from a gradual change in a medium. Okay, so refraction we are discussing, in refraction we are discussing two different medium. Okay, so a wave will be coming and it will move from one medium to another medium. Okay, so because their speed will changes, when wave is moving from one medium to another, its speed will be affected. So what will happen? It will change its in the direction of the wave. Okay, wave direction will be changed. Suppose if a wave is passing through a prism, okay, so a wave is diffracted, and with a slightly different direction, it will change its pattern. Okay, and so in this way, we will see the refraction clearly. Now here I show you the diagram in which I show you the refraction pattern. This is a glass, incident ray is coming, and if you look at the emergent ray, so it is slightly change its direction because the first medium is air, second medium is glass. So when the ray is moving from the air to the glass, so there are two different mediums. So when moving from air to glass, it slightly change its direction. This change in direction is because the speed changes. Okay. So glass refractive index is 1.33 and air is 1.003. So this is the example of refraction. Now here I show you a simple example of refraction from our daily life. If you insert a straw in a glass of water, so if you look at from the other side, you will see the straw is not in a straight line. So why? Because refraction is here. The straw inside the water and outside is air, so there are two different mediums, so it slightly change its direction. Okay, now diffraction is that when diffraction refers to a various phenomena that occur when a wave encounters an obstacle or a slit. It is defined as the bending of waves around the corners of an obstacle or through an aperture into the region of geometric shadow of an obstacle or aperture. So diffraction is now, it is actually the bending of waves. Means अगर रास्ते में कोई slit है, कोई रुकावट आ गई है small सी, so the wave will bend through when it will pass through that obstacle, means कोई रुकावट. So the pattern that is formed will be diffraction. The bending of waves around the corners of an obstacle is diffraction, and it occurs when some obstacle or anything, the small distance that came in front of the wave. Here I show you the example of diffraction. If you look at the first one, इसमें जो स्लिट है, जो डिस्टेंस है, ऑब्स्टिकल जो है उसका डिस्टेंस ज़्यादा है, तो डाइफ्रैक्शन कम हुई है, लो लेवल ऑफ डाइफ्रैक्शन. द सेकेंड वन में डिस्टेंस कम है तो डाइफ्रैक्शन ज़्यादा हुई है. ठीक है, जितना कम डिस्टेंस होगा उतनी ही ज़्यादा डाइफ्रैक्शन ज़्यादा होगी, हाई लेवल ऑफ डाइफ्रैक्शन होगी. Here I show you another diagram in which there is a diffraction pattern. If you look at here, this is the antenna and this is a mountain, and another side is any home. Okay, so the antenna rays are coming, and when it will incident on the mountain, so there will be diffraction and the waves will bend. Now I'm going to show you a video. In this video they explain the diffraction and rarefraction. So hope you will understand, hope you will be able to understand more.
Dear Tim and Moby, I don't understand the difference between refraction and diffraction. Can you explain it to me? From Nuria. Good question. Refraction and diffraction are both important properties of waves. Let's look at light for a minute. Light is a form of energy that zooms around as both waves and particles, or photons. Normally, light goes straight, minding its own business unless something gets in the way. But if it goes into a new material, like for example air, water or glass, it bends. This bending is called refraction. Well, it happens because light changes speed when it travels between materials of different densities. If you look at something in a pool of water, you can see refraction at work. Water is denser than air, so when light goes from air to water, it slows down. This slowing causes a shift in the light's direction. The underwater object looks all distorted and funny. The amount the wave bends is known as the angle of refraction. Different colours of light have different angles of refraction. Rainbows happen when all the colours making up white light refract at different angles through water droplets. Well, diffraction is a little different. Diffraction is the bending and spreading of waves, usually around an obstacle. Just like refraction, diffraction can happen with any kind of wave: light, sound, radio. No. Waving hello doesn't count. One example of diffraction is when waves spread out from a single source. If I shout something to you across the room, a bunch of sound waves come out of my mouth. Like this. The sound waves don't all go in a straight line. They spread out so you can hear what I'm saying pretty much anywhere in the room. Waves diffract when they hit obstacles too. Well, say some waves hit a barrier with a small hole in it. The waves will pass through the hole and spread out on the other side. If there's more than one hole, the waves will overlap on the other side, making a predictable interference pattern. Actually, diffraction is really useful. Scientists use diffraction of X-rays to make images of very tiny objects, like DNA, and very distant ones, like stars. I thought I told you those waves don't count. Oh yeah. Those are real waves, all right.
Okay, students, hope you will understand. And your assignment is that you have to give me examples of refraction, reflection, and diffraction from a daily life routine. And you have to practice on all the work which we have done. Okay, best of luck.